Okay, this is a Pythagorean forfeit. So if you're reviewing for the test and you're using this as a study guide, here are 4 questions you will potentially see on your test. If you want to try them again, just press pause, try the 4 questions, and then press unpause, and you'll see the answers to all 4 questions. The first question gives you a triangle with side lengths of 20, 30, and 40. It says, is this 90 degrees? Well, if it is 90 degrees, then there's 2 ways to determine it. You can simply put squares onto each of them, identify this as a leg and this is a leg, and say, well, this area, which is 20 times 20, which is 400, and this area, which is 30 times 30, which is 900, must equal this area, but 40 times 40 is 1600, and therefore, that's not a 4, that's a 9. Therefore, 400 plus 900 does not equal 1600, and therefore it's not 90 degrees. Okay. Another way you could have done simply wrote the formula, and when you did so, you would have ended up with 20 squared plus 30 squared equals 40 squared. And when you simplified it, you would have realized you got the exact same thing. And since they don't equal each other, you'd put a little do not equal sign there, and you would have had the exact same thing we wrote up here. But either way you do it, you prove that that is not 90 degrees because it doesn't fall into Pythagoras. The second question gives you a right triangle and asks you to identify 2 things, x and y. So the first thing it gives you is the area of this square attached to what is one of the legs. And then it also gives you the actual leg itself. So the first thing I'm going to do is I'm going to draw a square onto that leg, and I'm going to put the number 100 centimeters squared, which would be its area. And the area of this square here plus the area of this square here equals the area of this square here, which is what y represents, which means that y is 196 centimeters squared. Now x is the side length of a square whose area is 196. And again, going to an easier one that we all know. If the area is 25, what's the side length? It's 5 because the square root of 25 is 5. Square root of 196 is a little bit harder, but x is equal to the square root of 196. Or, if I take my calculator and go, what is the square root of 196 and say square root, it says 14. So therefore, x is 14 centimeters long. Your third question asks you to estimate the square root of 33 using a number line. So on your test, what I would expect you to put is the square root of the 2 perfect squares that the square root of 33, which is not perfect, falls between. That would be the square root of 25 and the square root of 36. So therefore, the starting point would be being able to construct an appropriate number line that looks like that. That's where the point. And then on your test, knowing that 33 is a little bit closer to 36, and therefore square root of 33 is roughly there, and putting somewhere between 5.6, 5.7, or 5.8-ish as a square root are all appropriate estimations. If we actually used our calculator and said, what is the square root of 33? It will tell you 5.7, which was our middle guess in our 3. But the range of answers that would be acceptable on a test would be 5.6, 5.7, and 5.8. And your last question is a doozy. Your last question has a lot of stuff in it, and it asks you to figure out a lot of different things. The first thing is it tells you that x is the diameter of the circle, that pi r squared is the area of a circle, and base times height divided by 2 is the area of a triangle. And then the question is, what is the area of that red part there? So the first thing I'm going to do is figure out what is the diameter. And since we have a right triangle with 6 and 6, if I attach squares to my imaginary, that's the world's worst square, I put 36 in here and 36 in here. Since those are both the legs of the right triangle, this will be 72. And the length of that hypotenuse will be the square root of 72, which we could guess, or we could say it's 8.5. So 8.5 roughly. Okay. So x is 8.5. I'm going to erase this here. I'm going to put 8.5 as the diameter. Okay. So now, if I think about the area of the circle, take away the area of the triangle. Does everyone agree that if I take the area of the circle, which would have been a full red circle, right, and I take away the white triangle, what would I get? I would get the area of the red that remains, correct? The area of the full red circle, take away the white triangle, equals the area of the red that remains. So a formula that will work, therefore, will be pi r squared, which is the area of the circle, take away base times height divided by 2. Think about that for a second. If that works, the area of the circle, take away the area of the triangle, should be what remains in red. 3.14 multiplied by, now here's the tricky part. If the diameter is 8.5, what is the radius? 4.25, right? Half of the diameter, right? Or 8.5 divided by 2. Half of $8.50 is $4.25. So I put 4.25 here, and I square it. Okay? So what I have so far is pi r squared. Pi r squared. Take away, now let's look at the triangle. The base of the triangle is 6. The height of the triangle is also 6 divided by 2. So if I look at this fairly complicated looking expression, this looks like it's way too complicated for grade 8 math, but it's not. It's pi r squared take away base times height divided by 2. And now we're going to use our bed math skills and solve this. Okay? So 3.14 multiplied by 4.25 squared. In bed maths, since there are no brackets to solve, the first thing we solve is exponents. So 4.25 squared will be 4.25 multiplied by itself, or squared, which is 18.0625. Take away 36 divided by 2. How's that? So far okay? Everybody's all right? Take our calculator again and take that big decimal number and multiply it by pi. And the area of the circle, if nothing was removed, is 56.71625. That's the area of the red circle if no white triangle was cut out of it. Take away the area of what the triangle is, which is 18. Right? The area of the red circle, take away the area of the white triangle, equals the final answer of 38.71625. That is the area of what remains, or the red. Okay? The area of the red circle, take away the white triangle, equals 38.71625 centimeters squared.